So for the video today, what we're going to be looking at is a little bit opposite of what we did on the last video. So what we're going to be looking at for this video is how to prove that two lines are parallel. Okay, so what you have right now, what you see in the picture, in the diagram, is that I have shown you that these two lines are parallel, which means that you know certain things. You know corresponding angles are congruent, you know alternate interior angles are congruent. But what if you didn't know that these two lines were parallel and somebody said, prove to me that these two lines are parallel given that angle 2 is congruent to angle 6. Okay, so you look at it and you think, all right, well, if angle 2 is congruent to angle 6, then that means that those are corresponding angles and they're congruent, so the lines have to be parallel. And that's exactly how I want you to think about it, right there. All right? Now, you see where I have corresponding angles written down here. That's what we usually use to say that two pairs of angles are parallel. Sorry, two angles are congruent if the lines are parallel. So what we're going to be looking at is what's called the converse of corresponding angles. Okay? Instead of saying if the lines are parallel, then angle 2 is congruent to angle 6, we say if angle 2 is congruent to angle 6, then the lines are parallel. We'll name the lines L and M. Then L is parallel to M. Same thing with alternate exterior or alternate interior angles. You'd be told, given that angle 4 is congruent to angle 6, are the lines parallel? You would use the converse of alternate interior angles. If angle 4 is congruent to angle 6, then L is parallel to M. Same side interior angles. So this is a little bit different. So same side interior angles we know are supplementary. So a pair of same side interior angles would be 4 and 5. So it would say, given that angle 4 and angle 5 are supplementary, so given that angle 4 and angle 5 are supplementary, are the two lines parallel? And you would say yes, by the converse of same side interior angles. If angle 4 and angle 5 are supplementary, then L must be parallel to M. And finally, the last one, alternate exterior angles. A pair of alternate exterior angles would be 1 and 7. You look at those and you know that they're congruent, so it's the same as the other ones with the converses. We would use the converse of alternate exterior angles. I'm kind of out of room, so I'm going to write this one over here. If angle 1 and angle 7 are congruent, so we'll put the congruent sign in them. If angle 1 and angle 7 are congruent, then L is parallel to M. So the type of question that you might get on this, I'm going to freehand this one. You would have two lines with the transversal, and it might be that this one's 50 degrees and this one is 50 degrees. And it would say, which line segments are parallel? Justify your answer. Okay, so let's get some labels on here. I'll put another line down here. We'd have A, B, C, D. All right? So looking at this, you have the two 50-degree angles, and they are alternate exterior angles if and only if these two lines are parallel and the red line is a transversal. So you would say DC is parallel to AB because you could either say because of the converse of alternate exterior angles, or if you didn't remember that, you could say if alternate exterior angles are congruent, then the lines must be parallel. So I apologize for this one being a little bit longer than 5 minutes. I had more stuff to talk about than I really thought, more stuff to explain. So after you finish this video, make sure that you go and do the questions that go along with it. And don't forget that I told you to work on the proofs that I gave you on Friday, that sheet. If you don't have it at home, it is on my website. And do not forget that there is a notebook quiz over all the notes from the videos and the questions from the videos, including this one. I hope that you've had a great weekend, and I can't wait to see y'all on Tuesday.